Hello, in this video we're going to go through an example of how to find the shortest distance from a point to a line. Now when I'm in my class I always start with this kind of question to the students. It's hard to do this because I'm drawing, I'm not a great artist, but let me attempt this. So this is me, I'm standing right here in front of the class, yammering on about something. So there's my board. And I say to the students, okay, I want you to pretend I am a point. Okay? So there's what I say to the students. And then I also say, pretend the wall over here, the wall is a line. Okay? I say, what's the fastest way for me to walk from where I am to the wall? And the answer is always a straight line. And this is often said with real confidence and assurity, and sure enough it is, but this isn't completely correct, because notice, in fact, if I was to walk from here to the wall, and let's represent, there are actually a whole bunch of straight lines that I can walk. So it's not just a straight line, it's a straight line, but the important part is that that line has to intersect with the wall at 90 degrees. So I always say, imagine if I put my arm out in front of me, I'm going to walk to that wall so that when my arm touches the wall, it's at 90 degrees. So let's look at an example, because maybe that picture confused you more than it helped you. So let's see if we can understand with an example. So we want to find the shortest distance from the point 7, -2 to the line y equals x minus 3. So again, I have no picture, so the first thing I'm going to do with this is, if I don't know what I'm doing, even when I do know what I'm doing usually, I'm going to draw a little picture. So let's draw this picture. So 7, -2, 7, -2 is somewhere around here. 7, -2, and then y equals x minus 3, so we're going to have a -3. So that's 0, -3, and I see I have a slope of 1. So I'm going to do this. Okay, that works. Alright, so now I need to figure out what the shortest distance is if I was to travel from this point here to this line. So again, it's the same idea. I'm going to walk, and I want to walk to this line, and I want to touch it at 90 degrees. So if I need to find the distance between the line to this point, if I had this point right here, then sure enough I could actually calculate the distance using the distance formula. Alright, so bearing that in mind, I need to have a little bit more information before I can do that. So, well, let's see what we need. If we want to find that point, if we extend this line on, this is really becomes the problem of intersection of two lines. So I need to figure out what line 1 is, and I need to figure out what line 2 is. So let's call, for our discussion, line 1 is the line y equals x plus x minus 3. Okay, and that's given to us in the problem. So let's write that down. Y equals x minus 3. So now the question comes, well, what is line 2? Well, since line 2 is perpendicular to line 1, that means that the slope of line 2 is equal to the negative reciprocal of the slope of line 1. So if I know the slope, and let's write this over here, the slope of line 1 is equal to 1. Therefore, the slope of line 2 is equal to -1. Alright, so now if I know the slope of line 2, what I can then say, therefore, we can say y is equal to -x plus b. And of course, now I need to find b. So since 7, -2 is on the line, I can use some substitution there. -2 is equal to -7 plus b. And then what I'm going to do is rearrange that. So that's going to be 5 is equal to b. And now I'm going to scratch my head for a second here and ask myself, does this make sense? That's very important. So let's take a look. So it's positive. That seems to make sense. And if I drew a scale diagram, I could probably pretty quickly work that out, that this is a valid answer. So therefore, I want to find this point. And again, really, whenever you're working, you want to communicate or want to find this point, let's name it. So that's C. So therefore, we need to find C. So to find C, we're going to take our two equations, y equals x minus 3 and y equals negative x plus 5. And we're going to go through and we're going to actually use elimination here. So notice, if you happen to be in grade 10 math, the unit very likely before this was systems of equations. So it's the same concepts that are carrying through. So if we add these two equations, we get 2y is equal to 2, so therefore y is equal to 1. Okay, well, if y is equal to 1, I can now sub that into either line, and I can get x is equal to 1 minus 3, which is equal to minus 2. So now I kind of scratch my head here, and I look at my diagram, and I think, uh-oh, that seems to suggest it's positive. So what I might do then is I might go back and check my work. Okay, let's check my work. So I see, okay, y is 1. So when y is 1, x is 1 minus 3. So wait a second. I was too quick here. I actually went and substituted y for x and moved some things around. So I think I've made an actual algebra mistake. So let's try this again. So therefore, I'm going to draw an extra step to make sure. So y is equal to x minus 3. So 1 is equal to x minus 3. Therefore, x is equal to 4. And I feel much better about that. So therefore, really nice thing to kind of grab onto here is the idea that you always go back to your diagram and say, does this make sense? Your diagram's not going to be perfect, so it's not always going to be able to help you, but often it will help you avoid the big mistakes like I just made right there. Okay, so let's keep going now. So therefore, let's change our color because we're kind of on to the next step here. So I want to find the distance between, and again, this point isn't named, so let's name it. Let's call this point B is 7, negative 2. Now I have an added tool to talk about my work. So let's find the distance between CB. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's equal to the square root of, and I'm going to write down C here to help me out. C is going to be 4, 1. So therefore, C is going to give me x2. So let's see, 7 minus 4 squared plus negative 2 minus 1 squared. So negative 7 minus 4 going to give me, 7 minus 4 is going to give me 3 squared plus, let's see, 3 squared. So that's equal to 3 squared is 9, the square root of 9 plus 9, which is the square root of 18. So therefore, the shortest distance from the point to the line is root 18. Now this is an interesting discussion here. Different teachers are going to ask for this in different ways. You could totally take this and plug this in your calculator and get a value, but it's okay to leave this as root 18. If there's a reason to substitute it in, then yeah, figure out what the decimal value is. But make sure if you do figure out the decimal, you say it's approximately equal to something. So just to kind of continue, let's actually do this. So a couple things here, like I was saying, I could take root 18 and I could actually calculate that. So I have my calculator next to me here, and I see that root 18 is approximately equal to 4.243. 3 decimals is fine, but make sure you notice I've changed from an equal sign to an approximate sign. Some people have looked at how to change a radical into a mixed radical. There's no requirement to do that, but what they might do is, you might see some people do this. I'm going to rewrite 18 as 9 times 2. What I've done is I've tried to figure out a factor of 18, which is a perfect square, because then I can write this as root 9 times root 2, and that's going to give me 3 root 2. Again, I am perfectly okay if you write it like this. Eventually we'll figure out, we'll formalize this process here, but I'm also okay if you do that at this point. I hope this video helped.